In previous videos, we've learned how to add and subtract radicals. So what comes next is how to multiply them. Might think that's actually easier. So we're going to start out with multiplying a monomial times a monomial, because you need to understand that basics before we go into binomials and trinomials. So we're going to multiply the outsides of the radicals, things like that. We're going to multiply the insides of the radicals, things like that. And then we're going to simplify. Okay, so let's look at this first example. 2 times 4 is 8. That's the outside. Then the square root. 3 times 15. Now that is 45. But because I'm going to simplify, I'm going to go ahead and write this as 3 times 15, which is 3 times 5. You can write it as 45. Nothing wrong with that. But since I know I'm going to simplify, I'm going to prime factor it anyway. And then to simplify square root, I'm looking for a pair. So that comes outside the radical, multiplies 3 times 8 is 24, and the 5 stays inside the radical. Let's look at the next example that has some letters. Multiply the outsides, which is 10, keep the radical, and I have 3y times 2x. I don't see any pairs, so I'm just going to multiply that together and get 6xy. That's all there is to it. Let's extend that concept to multiplying monomial times a monomial, except it's the same thing. So we have the same square root. Well, think about it. If you multiply something times itself, that's the same as squaring it. If you have something that's the square root squared, those are what's called inverse operations, and they cancel each other out. So the square root of 3 times the square root of 3 is the square root of 9, which just gets you the 3. So when you square a square root, it cancels each other out, and you just get a 3. So what happens when I multiply the square root of 7y times the square root of 7y? You just get 7y. Again, if you square a square root, those two things cancel each other out and you just get the 7y. What about this? We have the square root of 5 minus y squared. So what's really happening is this and this are canceling each other out, and you just have 5 minus y. If you can remember that, that's going to save you some work in the next few examples. So now we're going to use the distributive property, and we're going to distribute that times all of those. So we're just multiplying a bunch of monomials. So we could rewrite this as 3 times the square root of 5y times the square root of 5y plus 3 times the square root of 5y times the square root of x plus 3 times the square root of 5y times negative 2 square root of 3. Now you don't really have to write that out, but I just want to show you that's really what we're doing. Since these are the same, what happens? You keep the 3, the square root squared cancel each other out, and you just get 5y. Here, the 3 stays on the outside, all of that's on the inside. And then here, a positive times a negative is a negative. Those are the outsides, that's 6. These are the insides, I see no pair, that's 15y. Let's take one more step, that's 15y plus 3 times the square root of 5xy minus 6 times the square root of 15y. I cannot simplify any square roots. I don't see any like terms. That's it. So I have performed the indicated operations and I have simplified my answers. Now, of course, we're going to do that FOIL. First, out, enter, last. We're going to simplify and we're going to combine like terms. Okay? So first, out, enter, last. So those two. So if you want to write it out, that's 4 square root of 2 multiplied by 5 square root of 3. Those two, that's going to be minus because I have a positive times a negative. 4 square root of 2 times 8 square root of 6. Then those two, again, that's minus 2 square root of 3 times 5 square root of 3. And a negative times a negative, that's going to give me positive 2 square root of 3 times 8 square root of 6. So we're just multiplying a bunch of monomials, all right? Outsides with outsides, insides with insides. So 4 times 5 is 20. That's the outside. That's 6. 32. Now that's 12, and we can write that as 12, but I'm going to write that as 2 times 2 times 3, because I know I'm going to have a pair. Minus the outsides, which is 10. And then, look at here, we have the square root of 3 times the square root of 3. That's the same thing. What is that? That's just 3. If you want to think about that, that's the square root of 9, which is still just 3. Outside, that's 16. Inside, that's 3 times, and 6 is 3 times 2. Again, you could write 18, then you need to factor it anyway. So I'm just kind of skipping that step. So here I have 20 square root of 6. The 2 comes out. Times 32 is 64. No radicals, that's just 30. 3 times 16 is 48. And it leaves that 2. I look at that. I have all these different kind of radicals. None of them are alike. There's no like terms. That's all there is to it. Okay, just take it a step at a time. Now we have something squared, but yet I have these notes here that says FOIL, because when you have something squared, that means to multiply times itself. So I'm going to write it out. So I know that first out, inner last. Okay, first is 3 square root of x times 3 square root of x. Then the outer, that's going to be minus 3 square root of x times 2 square root of y. The inner, minus 2 square root of y times 3 square root of x. And then last, negative times negative is positive. 2 square root of y times 2 square root of y. So let's just take it one thing at a time. Outside times outside is 9. And then look at what we have. We have the exact same thing under the square root. So the square root of x times the square root of x is just x. That's right. Minus the outsides, that's 6. The insides is xy. Minus the outside is 6. The inside, write it in alphabetical order, is xy. Then here we have plus. 2 times 2 is 4. And once again, square root of y times the square root of y, that's the same thing. That's just y. So I've simplified everything. Do I have any like terms? Yes, I do, because now those radicals are the same. So I'm going to keep 9x. I'm going to keep the plus 4y. But remember, when you have like radicals, you keep the radical, but you add or subtract the coefficient. So negative 6 and negative 6 is negative 12. So write it out twice because of that squaring, a step at a time, first out, inner last, that FOIL method, simplify, combine like terms. We're going to do another squaring, but it looks a little bit harder. So again, I'm going to write out what this squared thing means, which means to multiply it times itself. First, out, inner, last. 5 times 5, that's the easy part. That's 25. Now, plus 5 times the square root of x plus 3. Outsides with outsides, so 5 times 1, insides with insides. Then here we have plus, same thing. And then we have the square root of x plus 3 times the square root of x plus 3. Hopefully you're thinking, I know what that is. All right, so I have 25 plus Are those alike? Yes, they are. The square roots are the same, so we keep the square root and add the coefficients. But what about this? What happens when you have the same square roots multiplied together? The square root of something times the square root of the same thing, the square root goes away, and you just have that x plus 3. Am I done? Not quite, because believe it or not, those are like terms. So I can combine those and make that 28 plus 10 times the square root of x plus 3 plus x. So let's look at this last example. Looks a little bit scarier. So again, I'm squaring a binomial, so I'm going to write it out twice. So I don't have to skip any steps. If you can skip steps on this, it's really okay. Okay, so first, out, enter, last. 2 times 2 is 4. Then here, positive times a negative is a negative, and these are outside the radical, so that would be minus 6, and then we have the radical of 5x minus 1. We have the inside, and notice that's the same thing. 2 times negative 3 is negative 6, and keep the radical. Then the last, so we have a negative times a negative is a positive. 3 square root of 5x minus 1 times 3 square root of 5x minus 1. Okay, I'm going to keep the 4. When you square a binomial, those middle terms are always going to be alike. So we have the same radical, and we add their coefficients, so that's negative 12. So that takes care of all of that. Now, what's this? We're multiplying. 3 times 3 is 9. Then the square root of 5x minus 1 times the square root of 5x minus 1. When you multiply the same square roots, the square roots go away, and you just have 5x minus 1. We're not done. I need to distribute. So we're going to have 45x minus 9. Still not done, because those are like terms. So 4 minus 9 is a negative 5. We have a negative 12. And we finally have a positive 45x. It does not matter what order you write your answer. So if you look in the answer key and it has this, those are the same thing. We're just adding and subtracting, have the same signs. Positive 45, a negative 12 square root of 5x minus 1, and a negative 5. Both those answers would be correct. But the key thing is if you have something squared, write it out twice. Those middle terms are always going to be alike, and you can combine them. And then remember, a square root times the square root cancels out the square root, and you just have what's underneath. One step at a time, you're going to do great.